we are supposed to remove all the d dt. This is solving differential equation, correct? We are supposed to solve this differential equation. So I look at what that is given to me here according to the format that I've learned. This is a variable separable kind of differential equation. I think solving differential equation is very, very easy in our syllabus because there's a limited kind of differential equation that we are supposed to know how to solve. So you are basically just following a very fixed set of rules by first identifying the condition. We just categorize it to the kind of differential equation that we solve. So this is a variable separable kind of differential equation. I think you guys probably already know about this, so I'm not going to elaborate on that. So treating this as a variable separable, I'm going to divide this 100 square over m square minus m square to the other side. So we have a 1 over 100 square minus m square. dm dt, this is equal to k. Integrating both the left and right hand side with respect to t, we have this integration of 1 over 100 square minus m square dm. This is going to be k, which is a constant, integration of 1 dt. On the left hand side, integrating this, I can either first try to manipulate this and change this into its partial fraction on the left hand side. This can be changed into a partial fraction, or I can also definitely make use of the formula that we have in our MF26. Let's take a quick look at it. Using the formula that is in our MF26, I am going to make use of this one here. So if I were to make use of this particular formula here, it is going to be equal to 1 over 2 times of A. In this case, is 100. Then we have a ln modulus of 100 plus m divided by 100 minus m. This is going to be equal to kt plus a, or we can see this as 1 over 200 ln of modulus of 100 plus m divided by 100 minus m modulus. This is equal to kt plus a. We need to pause for a while. I need you to see this very, very clearly together with me, okay? Let's check out this question again. This question, part 1, is a 6 marks question. Okay, part 1, can we see here? It is a 6 marks question. I need to discuss with you this today, which is going to be a continuation of what I have been trying to cycle you guys to think for the last few weeks, right? Of the 6 marks that is going to be awarded for this particular question, how many marks do you think I've gotten so far? Let's think about this together. How many marks do you think we have gotten so far? The question asks us to write down the differential equation. Every question, every part of the question that they ask, if I'm able to answer it right, I must be able to get at least 1 mark, correct? So I believe, although I find very, very little value, but I believe here is where I probably would have already gotten myself 1 mark, okay, since they asked. Okay, but it's a very, very easy mark to get, because the question literally tells me something that is like this is happening, right? It is proportional. The rate of growth is proportional to 100 square minus m square. Probably way easier than, like I have not read the SAJC question, but probably way easier than what SAJC said for what Caitlin has mentioned just now. So 1 mark it is here. And I think doing this is actually very, very easy. For schools that are a little bit more stingy, right? I don't think they are going to give a lot of marks for this. Because this one is super easy and you can actually integrate this using what you have in MF26. So can we be a little bit stingy today in terms of giving marks? So if I am stingy enough, right, I think this should probably also get me another 1 mark. Maximum 2, maximum 2. Okay, even if we are generous, right, maximum 2. But if you are a bit more stingy today, it is going to be 1 mark. Let's look at this question again. This is a 6 marks question. If we are stingy enough and we are allocating marks for ourselves, right, we have gotten 2 marks. You know what we have just gotten for ourselves? We have just gotten ourselves 2 marks out of 6 marks for what we already know how to do for differential equation. And what is the question asking me to do? The question is asking me to find m in terms of t. You know what is going to come next? The next part of this, the rest of the solution, right, is just trying to re-express this equation here to make m the subject. Can you see the focus of this question, which is also something that I've been telling you guys for the last few weeks, right? A lot of JC students, they miss this. They miss the fact that in a typical solution, it is not just going to be the things that you learn in a book that's going to get you the marks. Because the next 4 marks that I'm going to be learning is not going to be learned from me trying to look at differential equation from my lecture notes. You check out, Achevas TV, which is so good, it is still not going to help you to do the next 4 marks. Because the focus has changed, okay? And we need to prepare ourselves for this change, or else, no matter how much you try to look at your school's notes, no matter how much you like blindly practice and practice and practice, you may not be able to get that additional 4 marks. And the questions that we are going to be doing today, right, are going to consist a lot of about this. This paper is not a difficult paper. Okay, I told you guys I rank every paper that I gave you, right? So this paper, I put it as a 3.5 to 3.75 out of 5. The one that we did last week, the CJC paper, I rank it as 2.5 out of 5. So this is a little bit more difficult. We are not getting to the really difficult one yet. So we are already looking at the question, and I can guarantee you, okay, there should be a lot of people who will fail this. And they don't fail it because they don't know how to do differential equation. They fail it because they cannot continue with the rest of the parts of the algebra smoothly enough in exam. If you give them time, they should be able to finish. But you must get this smooth enough in the exam. So let's just do a quick recap of what is our focus in our H2 math. What is the change that we are experiencing for a question that is like this, if you were to appear in our exam? The change is the way that we solve problem has been changed. In a secondary school, the way that we solve problem is more instructional. You solve a problem based on what they tell you how you can solve a problem. So you follow a set of instructions. This is a very instructional way of solving problem. Solving a differential equation. It's very, very easy, fast to learn. As long as you put in effort to read up your school's notes, right, you should be able to do this part. But this kind of problem solving is very, very secondary school A math. So let's move on to the H2 math version. You're still solving problem, but you're solving problem by developing something else. Okay, and that something else is what a lot of people, they didn't manage to capture for the last 1+ years in your J1. And now I think it is a good and appropriate time, especially after our topical revision during our June holiday, right, where we are so soaked with all those knowledge and concept of H2 math. We are ready to really tackle this part, which is solving problem, which require us to independently think and strategize. Okay, so let's go through the next part, and we want to make sure that we think together. Thinking can be trained. How do we train ourselves in terms of thinking? The more we think like together now, the more you make sure that you think when you're doing your practices, the less you need to think during the exam. You can actually transfer that thinking from the exam to your practice. The more you're able to transfer that, the easier you're going to get marks in the exam, because you think first before you even step into the exam hall. So let's try, okay? Let's try to experience. I have already gone through the thinking process. So let me just synchronize a little bit, okay? If I'm using red color, that is when I am thinking, and I'm going to produce for you a solution which is good enough, but it's not the best. So I'm going to make some changes to it, okay? Just so that we can think together. Okay, then black color will be replacing my red colored solution. So the black color one is what I feel it is the best. Yeah, I may not be able to like 100% produce that in exam, but I just want to go through the thinking process. So for example, here, right, I know in order for me to make m in terms of t, and with the information that is given to me, I should be solving for whatever arbitrary constants that I've introduced into the equation, which means that other than making m the subject, which is what I'm so used to in the secondary school, Sec 1, Sec 2, we have already learned how to make something the subject. Okay, we need to do 2 more things, which is to solve for k and to solve for a, because k and a are what I've introduced into my solution. We need to recognize this. Okay, I don't want to wait till the exam, right? Then I'm actually still not very sure whether I'm supposed to solve for k and a. Okay, because I introduced it, the question didn't talk about it, and whenever it is possible, you should try to solve for them. So what if I were to try to, looking at the situation, when should I solve for k, when should I solve for a? I think whenever it is convenient. If you were to ask me, right, now seems to be a convenient enough time for me to solve for a. Let's see what is going to happen if I were to solve for a now, okay? So let's explore together. In order for me to solve for a, I can see I can see that when t is equal to 0, m is equal to 5 is perfect for me to solve for a. You know why? Because k will disappear, right? When t is equal to 0. Okay, let's make sure that we think together, okay? Because in exam, we won't have such time to think. And the more that we can do that now, the better the situation is going to be for our exam. Okay, and we are not doing H2 math concepts anymore. Okay, we are doing something that is harder, something that is even more difficult to acquire. We need time to acquire this. So I'm going to make use of the fact that when t is equal to 0, m here is equal to 5. So we will have a 1 over 200 ln of modulus of 5. Substitute that in. We have a 105 over 95. This is going to be equal to 0 plus a. Okay, we have solved for a. A is going to be equal to 1 over 200 ln of 105 over 95. What is this? 105 over 95. This is equal to 21 over 19, which is a positive number. So with or without the modulus, it doesn't really matter. I'm going to just leave out the modulus. So I've solved for a. I probably will get a little bit of marks from here. Okay, but let's see how it is going to feel if I were to continue from here. Okay, so it is going to be 1 over 200 ln of modulus of 100 plus m divided by 100 minus m. This is going to be kt plus a, 1 over 200 ln of 21 over 19. I still need to make m the subject. I can see that I am a little bit burdened now by the algebra that is appearing. Okay, so the algebra, I mean, we must imagine, okay, whatever I'm doing here, right, I am going to try to like manage this in exam also. Whatever that I feel I probably won't be able to manage in exam, even if I have a lot of time to do it now, right, I want to see how I can think and make some strategic changes. So this is preferably not something that I want to experience in exam. It's going to slow me down. But let's continue first. I think we can at least still do a bit more. Should I solve for k? Maybe I can solve for k. Maybe I can solve for k, because if I were to use this piece of information, I can probably solve for k. I don't know how burdensome the next algebra is going to be if I were to solve for k. Maybe let me do a little bit of change first. So what if I were to do a ln of modulus of 100 plus m over 100 minus m. This is going to be equal to 200 kt plus ln of 21 over 19. Okay, this ln of 21 over 19 is very painful for me to look at it from in my equation. There are two ways that I can think of now for me to reduce the burden of having this in my equation. One is to bring it over to the other side. So I'll have ln something minus ln something. Okay, ln something minus ln something, I can very easily collapse the ln, make it into ln one single expression, right? So that's one strategy. The other one is I remove this ln here. Removing this ln here is surprisingly useful also in terms of my algebra, because I will have this. This is going to be equal to e to the power of 200 kt plus this, or I can also write it as e to the power of ln 21 over 90. I mean, you guys do know, this was the secondary school stuff, e to the power of ln x is equal to x. Okay, you know this, right? Okay, please make sure that you know this. Okay, it's very, very useful. So this will become e to the power of 200 kt. This will become just 21 over 19. Okay, this is secondary school stuff. Any questions so far? We are still exploring. We are just doing algebra. Okay, and this algebra is it's not easy to do in an exam, okay? This kind of algebraic friction, this kind of algebraic challenge appears a lot of times in, like, for example, differential equation. It appears, for example, in differentiation question. Okay, just now I was talking to one of you guys, you were telling me about the problem with differentiation. Usually it is something that is like this, very algebraically intense. So you're actually planning and thinking through your algebra. It's a skill that you are acquiring that is not really from learning H2 math concepts. You're learning it from H2 math problems itself. Okay, we are shifting our focus to think. So we have this, and I have another problem. Because I will need to remove this modulus. So to remove the modulus, we will have a 100 plus m over 100 minus m. This is going to be equal to plus or minus 21 over 19 e to the power of 200 kt. And we have not even solved for k, okay? We need to solve for k. So we have a plus or minus. This plus or minus is also going to be very, very painful. We need to find a way to remove this plus minus. Okay, I can think of two ways to remove this plus minus. Let's think together. The first one, which I think is the easier one, is the fact that this question here, right, is telling us that we are looking at the rate of growth. The rate of growth immediately tells me that dm dt is going to be positive, the rate of growth. M must be increasing as t increases. So the rate of growth tells me, hints to me that this is going to be bigger than 0. And if this were to be bigger than 0, it also hints to me that m should be a number that is between 0 and 100. So that 100 square minus m square can be positive, correct? Okay, so if I'm able to capture this hint, okay, that's why in the very beginning, I need to explore and look at the situation that I'm in, which is what a lot of people, they miss, you know. I mean, if it were to be me, right, if I'm rushing through the exam, it is very, very easy for me to miss information that is given to me by the question, and I may accidentally break out of the boundary of how I'm supposed to solve the problem. The moment when I go out of the boundary, it's very difficult for me to hit the goal because the goal is within the boundary. So I would never want to cross that boundary. So anyway, if I can see this, then I know that this is definitely positive. But I know that 100 minus m is going to be positive. So based on this, okay, I probably should do some explanation. Then I'll most likely adopt the positive. Okay, that's one way. But okay, that's one way. That's one way. But if you think about it, this way of reducing the plus or minus, right? Sometimes it's not very, very sustainable because in a lot of differential equations, they don't really tell you that it is increasing or decreasing, right? They will just tell you the rate is this. Okay, so assuming that they didn't actually tell you that it is rate of increase, rate of growth is rate of increase, assuming that they didn't actually tell you this, right? Then how should we determine whether it is plus or minus? What I will usually do to determine whether it should be plus or minus, two things. One is I read the question, which sometimes the information may not be there. I'm glad that for this particular question, it is there. Another one that is usually more consistent is I sub numbers. Let me show you what I mean by subbing numbers. I can choose either this or this. I'll definitely choose this. If I were to choose this, I may have a problem because k is still an unknown. So I'll still introduce k inside, which makes my decision harder. All these things that I'm trying to talk to you now, right, are really the thinking process that you are supposed to like execute in split second during the exam. Okay? Which one to sub in, you know, so we want to make sure that we are more and more accustomed to this, okay? So I think I'm going to try to substitute this in. For example, when t is equal to 0, m, I know it is going to be equal to 5. So if I were to work on the left-hand side of this equation, we're going to be getting a 100 plus m, which is 5, divided by 100 minus m, which is 5. So this is going to give me a 105 over 95, which is equal to 21 over 19. So this is positive. So if t is equal to 0, m is equal to 5, the left-hand side is positive. The right-hand side must also be positive. That's why I will just go, I'll remove the plus or minus. I'll probably say that therefore, I know 100 plus m divided by 100 minus m. This is going to be positive 21 over 19 e to the power of 200 kt. Then I'll go on to try to solve for k. Okay? A lot of thinkings are involved. Okay, and that is why we didn't really get much chance to go through this during the 4 weeks plus of topical revision that we had during June, because then we were focusing on topics. Okay, now is the important part. We have 3 months plus to 4 months to try to work on this, and it is more than enough. As long as we get the topical ones right, this part will come. Okay, but you need to focus on this kind together with me. Okay, this kind is not easy to get because you can't read to get it. And for some of you, the reason why you didn't score, I believe, in the exam especially, is because of this kind of thinking process that we are lacking. But it can definitely be trained. How do we train that? We think. We just make sure that we think. We make sure that thinking is part and parcel of my practice. We make sure that we don't look at the solution too soon, because the solution prevents me from thinking. The solution sucks me into reading the algebra. And by reading algebra, we don't think. Number one. Number two, it's not like I cannot look at the solution. I just need to delay looking at the solution. By delaying, it gives me more time to think. And I need to make sure that my reference, my school's notes, the Achevas outline, whatever references that you have, right, are right beside me. Because those are what that is going to give me all the skeleton so that I can continue to think. So you don't put aside your references as you're doing your revision now, okay? They are, like what I told you before, I know there are a lot of people who will just chunk aside their notes, then do papers as if they already can do the entire paper. No. But of course, if you're going to go through a question thinking like how we are doing it like that now, right, it's going to be a huge burden. You're not going to be able to finish any paper. So I just need to have one objective. How to conduct the thinking stuff, you leave it to tuition. We are going to do it together. But for I just need to try to do one thing, which is when you're trying to do a question, try to complete the question yourself as much as possible. The aim of completion will usually already force you to think throughout the entire process. We're going to feel this today, okay? We're going to do just a few questions today, and we're going to try to complete them as thoroughly as possible. Okay, so your aim is to just complete. Don't do half-half, then after that, you give up, go and watch TV, then look at solution, ask friends, ask tutor. Try to see how much you can complete, as much as possible by yourself, completion. Anyway, coming back to thinking, right? I do believe that this entire process can be shortened. Can I share with you something, which is this modulus? This modulus part, right, I have a strategy. It may not work all the time, but I think this strategy is way better than everything that I'm writing here. It's a bit smoother. For example, from here, let me show you what I will probably try to do, okay? Try as in like, I may need to switch my strategy halfway, but I'm going to try this. I will usually try to remove the modulus first before I try to solve for the constants unknown. Sometimes it's just very, very smooth, the process. Let me show you. If I were to try to remove the constants first, okay? Sorry, I will try to remove the modulus first. Okay, let me explain to you how I will remove the modulus. So I have a ln modulus of 100 plus m divided by 100 minus m. This is going to be equal to 200 kt plus 200a. Then we will have a modulus of 100 plus m divided by 100 minus m. This is going to be equal to e to the power of 200 kt e to the power of 200a. And I'm going to remove the modulus, which will give me a 100 plus m divided by 100 minus m. This is plus or minus e to the power of 200a e to the power of 200 kt. This is how I plan to remove the modulus because of something that the school has taught me, which is I will always chunk all the arbitrary constants together to make it just one nice alphabet. For example, here, what I'm going to do next is, instead of managing A, I'm going to replace this entire thing by B. B to the power of 200 kt. Where I know what is B, B is equal to this plus or minus e to the power of 200a. To me, this is perfect. Because differential equation always allow me to group constants together to form one arbitrary constant. And the moment it is grouped into an arbitrary constant, right, I just need to solve for it later. It will automatically become a number if it is possible. So rather than me managing A, and then because A is going to morph into this form, that form, this form, that form, in the end with a plus or minus, right? How about me letting an arbitrary constant suck all this complication into that simple alphabet? Arbitrary constant, it is perfect. It just keeps sucking all the expressions right into it. Not expression, variables, I cannot let it suck. You suck all the numbers, all the plus, minus, it will all suck into it and it becomes this. Let's see how it is going to feel if I were to adopt this strategy. Because this strategy can in a way become my default when I'm doing my differential equation again. I mean, we do see this a lot. It is not a strategy that's going to go into waste because it is such a common thing to see, right? This modulus, if you have done differential equation, you would have seen this. And we can plan for this first. When you see a modulus in differential equation, just see whether you can let that arbitrary constant suck away that modulus. Okay, then you see what can be done next. If it is not possible, then fine. At least I can make this the default. Halfway through, I find that it's not good. I can switch to try something else. But if I get this, I'm going to try again. When t is equal to 0, m, I know it is going to be equal to 5. And on the left-hand side, we have 105 divided by 95. This is going to be equal to a nice b, e to the power of 0. This tells me that b is equal to immediately 105 over 95, which is equal to 21 over 19. Therefore, I know that 100 plus m over 100 minus m, this is going to be equal to b, which is 21 over 19, e to the power of 200 kt. Nice. Because I have removed the plus or minus. Not removed, I've decided whether it is plus or minus by doing a substitution, and I solve for the arbitrary constant at the same time. So my entire process is a little bit smoother. Can you see the difference if you were to do this question in the exam without actually preparing for the thinking part, and your aim is to just blindly going through the algebra all the time, as if every single time when you go through the algebra it is new, just make m the subject, just make m the subject. Okay, as compared to what we have tried to plan now, and you think about it, if you think about it now, in the exam, don't you find that there's going to be a higher chance for you to get it correct because the whole entire algebraic process is going to be smoother? Let me show you another thing that you can try. This I actually learned only when I'm teaching H2 math, because normally people won't try this. So let me show you another one. I love this other strategy. Is how I'm going to solve for k. Okay, this may or may not work, but the moment when I think through it and I get it once, right, whenever I can try this, I will just automatically try this. But I must make sure that I go through this thinking process at least once. So I can feel, you know, like this is slick, you know, I just automatically adopt this. So let me try to solve for k for you to see, okay? Let me solve for you how I think usual people will solve, which is me, okay? If I didn't try this, right, I'll solve it this way. So to solve for k, I'm going to make use of this piece of information, definitely. I can't make use of this because t is equal to 0, k is just going to disappear. So I'm going to make use of this piece of information. Okay, I'm going to solve for k a bit more inefficiently, okay? So this is 5 and m, this is equal to 20. So we have 120 divided by 80. This is equal to 21 over 19. E to the power of substituting 5 in for t, we have a 5 times 2,000, we have a 1,000 k. Okay, so I'm going to divide this across to the other side. So we have e to the power of 1,000 k. This is going to be equal to this divided by this is equal to 19 over 14. So 1,000 k. This is going to be ln of 19 over 14, and k is going to be 1 over 1,000 ln of 19 over 14. Is this correct? Absolutely correct. Will you get any problem if you substitute this in and continuing to make m the subject? You will have no problem. On the superficially, you have no problem because you're not doing this in the exam. Time is, you're not rushing for time, you know, you don't mind doing something that is overly burdensome in terms of algebra. So you are going to be getting this 100 plus m over 100 minus m. This is equal to 21 over 19 e to the power of 200. This is going to be 1 over 5 ln of 19 over 14 multiplied by t, and then you're going to make m the subject. Okay, you're going to get this. Don't treat this as if it is a revision. Treat this as if you are doing this in an exam. Won't you find that this is going to be a, like you turn yourself off, you know, like, goodness, you know, this is such a turn off. I don't want to try whatever that I'm doing. So, although there's nothing wrong, that's the thing, there's nothing wrong with this. Okay, there's nothing wrong with this except whether I will really want to do this in the exam. So let me show you another strategy, okay? This is a very, very nice and slick strategy of how we want to solve for k by making a little bit of improvisation. I'm going to change this to make it look like this, 21 over 19 e to the power of 200k, then the whole thing to the power of t. Sometimes it'll work. Okay, I mean, I can't really tell when it's going to work. To me, it's still a little bit like a feeling. So just know that, you know, what if you were to do this? Let's try, okay? Let's try and let me show you why this is actually going to work pretty well in the exam. Okay, then you try to see whether when you are able to apply this when you're doing some of your own revision. So if I were to try to write it in this way, right, I'm still going to try substitute when t is equal to 5, m is equal to 20. So we will have 120 over 80. This is equal to 21 over 19. E to the power of 200k, then this is going to be 5 to the power of 5. Okay, I'm putting it this way, right? It's because I don't actually plan to solve for k. I plan to solve for e to the power of 200k, which I can also rewrite it as c. Okay, it depends on you. If you are more comfortable in rewriting this as one single arbitrary constant, might as well just do that. Your aim is to just keep collapsing everything into one single arbitrary constant. Okay, so for some of you who are not very into looking at it in this way, you can just easily rewrite it as this over 19, then c to the power of t, then solve for c. Your aim is to just collapse everything that looks complicated algebraically according to what you can into one single alphabet. The moment you can collapse, a lot of burdens are going to be removed. Okay? So to me, this c, I think I'm fine. I'm going to just leave it as it is first, which means that I will have a e to the power of 200k, the whole thing to the power of 5. This is going to be, just now we found, right, 19 over 14. So this tells me that e to the power of 200k, this is 19 over 14 to the power of 1 over 5. And therefore, we have a 100 plus m divided by 100 minus m. This is equal to this, which is 21 over 19. This, I'm going to replace it with 19 over 14 to the power of 1 over 5. To the power of t, then this 1 is going to be 1 over 5 times t, so we have a t to the power of t over 5. Still complicated, but at least this is the most efficient way that as of now I can think of to try to come up with the entire solution. Okay, and I just want to see whether I can experience this or think about this myself when I'm doing my work. Okay, like what I was telling you, I don't expect you to just keep thinking about all this, you know. Whatever you write, right, you just need to think, how can I complete it? You know, if I'm completing it this way, am I also going to try to complete it in exactly the same way during the exam? If I'm not, is there anything that I can just do a little bit of improvisation and change so that it is a set of solutions that I know, okay, I can actually reproduce again in the exam. You just need to make this your aim. I think it is more than good enough. And this is how we're going to try to score for the next 4 marks. We are not done yet. We're not done yet because we have yet to make m the subject. Okay, but just by exploring this, I'm already exploring with you about the problem with modulus. Then after that, we explore about, you know, something that is like this. And we sort of like concluded that anything that is complicated, right? If it is algebraically possible, I'm going to just group all the constants together to just make it into one huge alphabet. It's always going to be a plus points. Okay? So far, any question? And remember, I'm just experiencing this with you because I can't give you a set of instruction. This is that part of H2 math, which is pushing us to become really, you know, at another level. From O level, we become A level. Let me show you one more thing. Okay, it is not going to be useful for this question, but in general, it is way more useful, which is how I'm going to make M the subject. Let me show you. We have M here, and to make M the subject, okay, this part is actually easy. Okay, to make M the subject, we can definitely do a bit of cross multiplication, this times this, which is going to be, okay, I'll times the 19 across to the other side. So I'll have I'll have this 1900 plus 19m is going to be equal to this multiplied across to the other side with the 21. So we have a 2100, then 19 over 14 to the power of t over 5, minus away 21m, then 19 over 14 t over 5. If I were to bring this over to the other side, we have a 21m, 19 over 14 t over 5 minus 19m. This is equal to 2100. 19 over 14 t over 5 minus 1900. This gives me m is going to be equal to 2100. 19 over 14 t over 5 minus this divided by 19 over 14 to the power of t over 5 minus 19. Okay, I will be getting this. This is okay. In fact, I think the solution has gotten something that is similar to this. This has one problem. The problem won't surface here, but that one problem, right, is a very common question that will be asked for this kind of question, which is if m, after you have gotten m, right, they'll ask you, what do you think is m in the long run? What do you think is m is in the long run? That means you're going to let t goes to infinity, correct? When t goes to infinity, what do you think is m? Looking at the expression that is given to you so far, and expecting myself to be encountering that kind of question where they want you to find m when t tends to infinity, you're going to then face with another roadblock, because it is not easy for you to analyze what m will become when t goes to infinity. You agree, right? And you can also remember such questions, which is a very common kind of question when you have this, right? So although this question didn't ask, part 2 and part 3, they're actually super simple. I don't think I will even want to talk to you about part 2 and part 3. You can go and try to look at it yourself. Although completion is a thing, but I think it is too easy for us for part 2 and part 3, so I'm going to skip it instead of completing this. But what if there to be a part 4, which is to find m when t goes to infinity? You can prepare for this. Okay, so we are going to prepare it now. Since the question didn't actually say that you are supposed to show it in this form or show it in any other form, how can we prepare for a situation where t may go to infinity? Okay, let me prepare that situation with you now, like you're going to be letting t goes to infinity. By doing this is very useful. So if the question didn't say anything, I'll usually do something that is like this. It will be 100 plus m divided by 100 minus m. This is going to be equal to, I'm going to rewrite this as 21 over 19, then 19 over 14 to the power of minus t over 5. This is what I'm trying to achieve. This. A negative power. Negative power is super good when we are discussing about when t tends to infinity. Because when it has a negative power, for example, a to the power of minus t. When t tends to infinity, what will this become? When t tends to infinity, this will tend to 0, right? Because it has a negative power. You understand what I'm trying to say? So analyzing tending to infinity question will be way simpler if I can prepare my algebra for it. Okay, that is why instead of trying to deal with to the power of positive t over 5, which I am expecting t to go to infinity, t is time, I'm going to try to manipulate it so that it is going to become power negative. Because power negative is way easier for me to try to analyze what it will become when t goes to infinity. Let's see what is the difference it's going to make. Algebraically, it's going to be the same. Okay, this is not as if it is very, I feel like algebraically it's not going to be simpler. It's just a preparation that I'm making. So we will have cross multiplying 1900, 19 over 14 to the power of minus t over 5 plus 19m, 19 over 14 to the power of minus t over 5. This is going to be equal to, let me erase this. We don't need this anymore. This is going to be equal to this times this. We have a 2100 minus 21m. Moving all the m over to one side, we have a 21m plus 19m, 19 over 14 to the power of negative t over 5. This is equal to 2100 minus 1900, 19 over 14 to the power of minus t over 5. Okay, I'm preparing this in case later they ask me, let t goes to infinity. So what is m? M is going to be equal to 2100 minus 1900, 19 over 14 to the power of negative t over 5 divided by 21 plus 19, 19 over 14 to the power of negative t over 5. So I'm going to go for this instead of this if the question didn't say much. So in case later on in this question, they were to ask me, hey, what do you think is the population size in the long run? So when t goes to infinity, I know the population size is going to go to 2100. This will become 0 divided by 21. This will become 0. The population size will tend to 100. Okay, all these can be prepared. If I were to just spend some time for one single question to think, we get a lot of value in terms of marks when I learn how to think and improvise for that particular question. Like what I've keep telling you guys, right? H2 Math is not trying to train every single one of you to become a math specialist. So they cannot possibly assign so much value to the math part. What they're assigning a lot of value to is the problem-solving process, more than the math. Math, all of us can choose and we can decide to pursue more math in a university next time. But now we are getting a very, very specialized subject, H2 Math, which helps us to solve problems that involves facts. With or without math, we are trying to solve problems when we are given facts. Let's try it one more time.